So we did a video a while back on the SCP exploiting the secure copy, and I thought it would be just sort of interesting to have a look in a bit more detail at how SSH works. SSH stands for Secure Shell, and it first appeared in the mid-90s as a sort of replacement for way of connecting to a remote machine over the internet. Up until that time, the technologies you had to connect to a remote machine, Telnet, RLogin, RSH, and so on, worked fine, but they transmitted all the data in the clear over the network. So if you logged into a remote machine, anyone with a packet sniffer between you and the remote machine could see everything you were doing on there. When these protocols first appeared, that wasn't a problem because the machines were probably only networked within the computer department of a university or a company. So the people who had access to do that were people who worked there, and probably the system administrators who had access to these things anyway. But as the machines got networked to other networks and you started to build the internet, if you had access to the network, any network that the data was traveling over, you could sniff the packets and see any of the data was being transmitted, including passwords and things. And so in 1995, Tatu Ulonen in Finland, I apologize if I pronounced that wrongly, was concerned about this. So he developed a protocol, SSH, Secure Shell, to sort of encrypt the data so that you couldn't sort of see what was being sent over the wire. You could see that data was being transmitted across, you could see how much data, you could see the frequency of it to a certain extent, but you couldn't see what the data was. So you could do certain types of analysis to see what's happening, but you couldn't see the actual data. And so SSH was developed as a way of encrypting the connection between two machines, but it actually does a lot more than that, because when you SSH to another machine, the first thing that happens is that you open up a TCP connection between those two machines, like any standard things. Although it doesn't have to be a TCP connection, you can actually specify that SSH uses any sort of reliable network connection to make that. So you could theoretically run it over an RS-232 connection, you could run it over the top of WebSockets and things like that. And I know people who have done that sort of thing. So you've got a reliable transport between the two machines, and so SSH is sending data over there. And what SSH does is it breaks the data down into a series of packets. And just like any packet transfer, these things have a few fields at the beginning. So at the top, you have something that tells you how big the packet is. So you have the packet length. There are 4 bytes saying the packet is this big. After that, you have another byte which tells you how much padding you've got. So you've got the packet length, you've got how much padding there is, and then you've got the data you want, the payload. Then you have the padding that follows that. And so what you do with each packet, after the payload, the data you want to send that's part of the connection, you add a small amount of padding, just random bytes. They don't mean anything, but they sort of force the encryption to sort of make it harder to detect what's going on because you've got random data in there. See some of Mike's videos for more details on why you want to do that. And then you have some sort of message authentication code there, so you know that the data here hasn't been monkeyed around with, that it's actually what was sent. You can then apply compression if you want to the payload, so you can compress the payload using standard compression algorithms such as zlib or something to compress the data. And then the whole of that packet, excluding the length, is then encrypted. The algorithms used for the encryption and for the message authentication code are selected by the server and the client. They establish that at the beginning, which ones they offer, which ones they want to use and things. So that they're established by the client and the server, so they vary from connection to connection. And you can offer many, and you choose the one that's perhaps best for that connection. We'll ignore that for the purposes of this video. So we leave the packet length unencrypted, because obviously we need to know how much data is coming. We encrypt the padding length, we encrypt the payload, we encrypt the padding, and we send the packet out over the network. At the other end, that's decrypted by the server, and it then knows it's got the packet of data, and it can piece it back together. And then the same thing is done for this packet and every packet, and the encryption is done so it's continuous. You start encrypting this one with vectors from this one and so on, so it sort of encrypts it one after the other. At the server or the client which receives this, you just reverse that process, so you decrypt the packets, you decompress the payload, and you can extract the data and sort of stitch it back together. So you start off, you've got your TCP connection, and that's unencrypted. And on top of that, you've got these packets which have been encrypted by the SSH protocol flowing on top of that. But that's not the end of the story. That's just encrypting the packets. That's not the connection that, say, if you SSH in, that's not your connection to the remote machine. On top of that, you then open a series of channels that you send the data over. And the reason for that is it enables you to multiplex multiple connections over that thing. So when I start a connection to my machine, it's creating a channel on top of this. So if this is our one computer over here, and this is another one over here, we're creating this channel here for our shell connection where we can communicate and control things. But this is actually being represented by a connection through the SSH packets. And we could have multiple ones of these between the same machines, or we could have different types of connections. So for example, SSH also allows you to forward any sort of TCP connection over there. So you can connect to a remote service via the SSH tunnel. So you can tunnel that through and it's encrypted and then sent out at the other end. And if we make the connection with verbose mode on, we can actually see it setting up that connection. So what we've got here, it's reading the configuration data, its local protocol string is. So it connects to the remote machine. It sends back saying, I support this version of SSH. I've sent what my version is. We've then exchanged information about our compatibility, what mechanisms we use for encrypting the messages, the packets over the network, and so on. We've checked that we know the machine. And then we get down to here, we're now trying to authenticate. So it's now establishing, okay, this is this user on that machine, so I can put my password in. And we're now connected. But if we look here, authentication succeeded, we're authenticated to the remote machine. And you see here, it's creating a new channel. So it's creating a connection, which again is just going to be, I send bytes down here, they appear at the other end. We send bytes the other way, they come back to us over this channel. And it's then setting up what type of connection it is. It's setting environment variables and things. And this is done by sending packets of data wrapped up inside the SSH packets, which establish that. Once that's done, we can then communicate and have our interactive session. So SSH is not just a sort of way of connecting a shell. It's actually got layers of things on top of that, which enable you to do lots of interesting things. So you can have multiple connections made over this thing. You don't just have to have one, and there's ways that you can set SSH up. So actually you make the connection and it stays connected when you finish. So if you then make another connection to the same server, it reuses that existing connection and multiplexes the two connections in between things. It can start and stop forwarded TCP connections to other addresses in both directions while the connection's running, just by sending different things over this connection. The reason why it's got all this functionality is that often, particularly in the Unix environment or the Linux environment, when you're connecting to other machines, you may just want a remote shell connection where you want to type commands and do things, that's great. But also the way the Unix X Windows graphical user interface works is that has normally done over a connection, usually TCP IP to port 6000, although it can be done over other things as well. And so that could then be forwarded as another connection so that you could log in into another machine and send the graphics commands back encrypted as well. Occasionally you may want to connect to a service behind a firewall, and you can do that by tunneling it through the SSH connection. So there's lots of reasons why it was built this way. But it's a nice feature, and I know I've been using this now for 20 odd years, 24 years probably now. But actually you're still discovering new things you can do with it. For example, the fact that you can keep a connection alive beyond when you've disconnected from the shell, so they can reuse that TCP connection, the lower level bits, when you create the new connection on top.
The more people you add to this group, so maybe you're a member of some kind of school thing, 50 people in the group, you're sending 50 messages, right? And if you're not sending a text message, maybe you're sending a video, suddenly the bandwidth becomes actually a bit of a problem.
The snake robot is performing sidewinding. Let's give it a little boost for speed.